Imagine looking into a mirror that not only reflects light, but time itself, looking not into your own face, but into the dawn of the universe, when existence was still folding itself around its first breath. That's exactly what the James Webb Space Telescope was designed to do. It is humanity's most ambitious cosmic time machine, with gold-plated mirrors so sensitive they can catch the faintest whispers of light that have been traveling for over 13 billion years. Webb's mission was clear: look farther back than anything before it, to glimpse the first sparks of creation. But what it discovered when it peered deeper than anyone had ever seen before was an infancy. It wasn't the cosmic cradle. It was a contradiction, an impossibility. A cosmic paradox so profound it has shaken the very skeleton of modern physics. Scientists for decades believed that they had a fairly solid understanding of how the universe evolved. Then the Big Bang, a blinding burst of matter and energy, then a vast, dark age, then the slow creation of the first stars. Galaxies would have hundreds of millions, even billions of years to develop and grow. The closer we reach to the beginning, the more things should be simple: separate clouds of hydrogen, unprocessed cosmic stew, faint flickers of wild, unorganized light. But when Webb pointed its golden eyes at a distant and allegedly peaceful portion of the sky, one of those huge black expanses where we anticipated no more than mere emptiness, it caught something that ought never to have been in existence at that moment: a mature galaxy. Not a ghostly, amorphous haze. Not an irregular batch of young stars. A great, spinning system with sweeping spiral arms and a gargantuan black hole hiding at its heart. A galaxy not just present, but booming, blazing with billions of stars that had no right to be there so early in the history of the universe. And then the shock: this was no accident. As more information flooded in, Webb's deep field view unveiled galaxy upon galaxy, each one fully formed, chemically evolved, and gravitationally sound. It was as though the cosmic timer had skipped ahead by billions of years overnight, bypassing the gradual slog of evolution we believed inevitable. With each look, a chilling question started ringing louder in scientific circles. What if everything we believed we knew about the start is mistaken? When Webb initially recorded the light from one of these ancient galaxies, seated over 13 billion light-years away, astronomers were looking for a ghost. A faint smear, hardly more than the cosmic background. In its place, what gazed back was architectural beauty: spiral arms curled like shining ribbons, thick clusters of stars in immaculate orbits, and a core aflame with energy. This wasn't a galaxy in the process of forming. It was a galaxy that had already completed forming, and with a dramatic flourish. To realize why this is puzzling, you must take into account the accepted chronology of galaxy development. Following the Big Bang, the universe was a thin, patchy haze of matter. Eons passed before gravity coalesced the matter into denser clouds, which collapsed into the initial stars. Those stars eventually congregated into rudimentary galaxies, small, irregular, chaotic. Only over billions of years would they develop into the grand spiral and elliptical forms we see today. But Webb's galaxies were bypassing the preteen awkward stage. They matured instantly. The physics of astrophysics forbade this. It was as if you discovered a redwood tree full-grown coming out of dirt that you had sowed the day before. Next came the chemical shock. When astronomers probed the spectra, the distinct signatures of light that indicate what elements are in these galaxies, they anticipated mostly hydrogen and helium, the plain building materials of the early universe. Instead, they discovered oxygen, carbon, even iron. These heavy elements don't materialize out of thin air. They are created in the hearts of giant stars and disseminated throughout space when those stars detonate as supernovae. But that takes time, hundreds of millions of years, at a bare minimum. Population 3 stars, first-generation stars, burn hydrogen and helium. They explode, scatter their heavier elements, and second-generation stars form from that enriched material. It's a cosmic recycling process, and it shouldn't have finished so soon. And yet here they were, galaxies younger than 400 million years and already bearing signs of several generations of star birth and death. The universe in its early days, it appeared, wasn't groggily coming to life, it was racing. And then the most ridiculous discovery yet. A supermassive black hole, more than 1 billion times bigger than our Sun, residing at the center of one of these youthful galaxies. In our universe today, that would be impressive but not surprising. In the early universe, it's cosmologically crazy. Black holes are believed to begin small, remnants of dead stars, and expand by consuming material around them over billions of years. Even the most enthusiastic growth models couldn't create something so huge in such a brief period. It was like discovering a mature adult born an hour earlier. Other scientists proposed that these could be primordial black holes, cosmic beasts created instantly from the extreme density ripples in the first fraction of a second after the Big Bang. Others floated exotic new physics with dark matter as the accelerator. But each new proposal meant ripping up the textbook and beginning anew. And the surprises didn't end there. As scientists input Webb's galaxy data into deep learning programs, they saw something strange about the positioning of these ancient systems. Their shapes and positioning weren't random, they were following a recurring mathematical ratio very close to the golden spiral, a pattern found in seashells, hurricanes, and even DNA. This wasn't just cosmic beauty, it was geometry. Structure. A hidden design stretching across billions of light years, as if the universe had been patterned from the start. If this was coincidence, it was a staggering one. If not, it hinted at something deeper, a fundamental law of nature we've yet to understand, or perhaps something even more provocative, intentionality embedded into the very fabric of spacetime. Then there was a more subdued, quiet discovery, the one that caused tremors of dismay across the astrobiology community. In what appeared to be a vacant area of interstellar space, ancient, cold, and presumed sterile, Webb spectrometers picked up the faint signatures of complex organic molecules. Not only simple molecules like methane, but polycyclic aromatic hydrocarbons, the chemical building blocks for amino acids, the very building blocks of life. They weren't on planets. They weren't within stars. They were floating through the emptiness, untouched after over 13 billion years. If true, this implied that life's building blocks were there nearly from the universe's beginning. Not a chance occurrence of planetary chemistry, but a built-in aspect of existence itself. And then came Webb in the image that still boggles the mind. 6 galaxies, spaced evenly, set out in petal-like fashion around a central bright thing, spinning in almost perfect harmony. Scientists called it the flower. There were those who proposed gravitational lensing was bending light to create the illusion. Others proposed quantum symmetries of cosmic proportions. But a small, unobtrusive minority proposed a much weirder idea. What if it were a message? A pointer? Something constructed to be apparent only when our technology was capable of perceiving it? It was then that the most disquieting hypothesis of all started to form. In quantum mechanics, the observer effect informs us that particles act differently when observed. But what if this does not end at the level of the microscopic world? What if the universe itself, at some unimaginable scale, is responsive? Some physicists detected subtle changes in Webb's data across time, not in the galaxies themselves, but in their tiny details, like observing them altered them. What if, having constructed Webb and looked into the earliest light, we discovered not just these ancient structures, but something we inadvertently set off? One of the most unsettling possibilities isn't that the universe is weirder than we thought, but that it's conscious. That somewhere, beyond time and light and inconceivable distances, something gazed back. Because what Webb saw wasn't merely about stars, black holes, or wandering molecules. It was about truth, such vast, such ancient, and such intricately entwined truth in everything that to see it is to sense reality shudder beneath your feet. We did not merely behold the unimaginable. We unlocked it. Galaxies too old, chemistry too complex, patterns too neat, signals too aware. Webb exposed the fact that the universe is not a passive backdrop on which events take place, it could be a player in the play. Perhaps complexity is not the end of the cosmic tale, but the start. And perhaps, when we finally constructed something that was strong enough to look back at the beginning of time, the beginning looked back.